So let's remind ourselves where we left off last time and finish our Connect 4 game and call this class history. And actually, just real quickly, let me jump into the final homework assignment. I just want to make sure that I cover everything that you'll need for the assignment. I think I'm with it. So let me just double check. Okay, yep, we're fine. All right, so as of right now, this is what our Connect 4 game currently does. So I hit play, it's saying it's this player one's turn. If I remember correctly, we just doing vertical wins. I think only vertical wins work right now, if I remember correctly. So player one can go column one, we'll do player two, column two. So there's player one wins. We'll run this again. I do not believe we have horizontal wins. Oh, I do. We do have horizontal wins. Well, I won. So let's look here. Is winner. Check for vertical winner. Check for horizontal winner. Oh, hold on a second. I may have taught this class before. Let's look at our version of this game. It's like, well, this is way farther done. Yeah, so let's try this again. Yeah, so as you can see, we used underscores. Dots looked better. All right, so that actually is kind of funny. Okay, so vertical is all that works so far. Okay, got it. So we're going to go back into our board. And for board, we have this concept of isWinner. And isWinner is going through, and we're going to check the entire grid, looking for a winner. Correct? And that's the way we're going to keep doing this for now. And then we're going to come back and we're going to look at a little bit more efficient way of pulling this off. All right, so this first part of the code here says, let's look for a vertical winner. So we're going to go through all of the columns. For each of those columns, we're going to go down the row. But we're going to start at the bottom of the row. So what that means is we're going to do this. If we're on column 2, we're going to go down here to the bottom and start working our way up to see if there's a vertical winner. Here, is there a vertical winner? So if I make the move 3, and now I'm checking, is there a vertical winner on 3? I'm going to come down here, and I'm going to say, here's my very first checker at the bottom. If that guy is null, and we're not looking, here, let's look at this code here. So if the current element we're looking at is equal to null, we're going to break out and move over to the next column. Otherwise, how do we handle last checker? If last checker was null, which we set it equal to null before we start counting up the column. If last checker was null, that is, this is the first checker we found of a certain color. We're going to set count plus plus. So count went from 0 to 1. Otherwise, if this is not the first checker we encountered, then if the current checker we're looking at is an instance of red checker and the last checker we were looking at was an instance of red checker, or the current checker we're looking at is an instance of black checker and the last checker we were looking at was an instance of black checker, then increment count. So if we found another one in a row. Otherwise, if the checker we just found is not the same color as the checker we previously found, set count back to 1. We just found a new color. Now we have a new potential start for a winner. All right. Each time through, we'll set last checker equal to whatever the checker is, red checker or black checker. Okay. At the end of each of those passes, we're going to ask, is count equal to 4? If it is, we have a winner. We'll return true. If count is not equal to 4 yet, what are we going to do? We're going to spin back up, check for the next one. If I'm out of checkers and count's not equal to 4, there was not a vertical winner in this column. Move on to the next column. So we'll break out of this inner for loop, go back to the next column. Otherwise, if this is the first checker we ran into, count plus plus. Otherwise, use the same question we asked before. Ultimately, keep asking, have we hit 4 in a row that were the same color? We have, there's a winner. All right, that makes sense for vertical winners. So this checks for vertical winner. For a horizontal winner, what would we have to do? I'll run this code real quick so we can see it. So this is my grid. How do I check for horizontal winners? Winners across this way.
Just do those, switch it, right?
Okay. Is checking for horizontal winners the same thing as checking for vertical winners if I switch rows and columns? So if I turn this guy on his side, isn't then it checking for horizontal winners? So this guy is checking the columns, right? This guy is checking the rows. If I switch those, so what if I say, well, this is actually going to be a little bit more difficult than just saying that. It almost works. It makes sense at first light. The difference is by turning it on its side, we can't necessarily assume that our first checker is over here on the left. That makes sense? So we really need to probably treat horizontal as its own one-off. But we can certainly start at column 0, go to the very bottom one and see, is this guy involved in a horizontal win? How do I check that? I can say, well, is the guy next to him a same color checker as, well, is he a checker to begin with? And is he the same kind of checker as me? If he is, count plus plus. If he's not, start over. So I'm really going to walk it from left to right all the way up, counting across each row. Make sense? Okay. Now, I cannot necessarily stop, though, when I hit an empty checker. What I mean by that, if I go to 2 and then I go to 5, is this an empty checker? Yes. That doesn't mean there's no checkers in this row. Is this an empty checker? Yes. Is this an empty checker? No. I have one in a row red. Is this an empty checker? Yes, but I'm not necessarily done. So my one in a row just went back to 0. To 0. To 1. Well, I clicked on something, but you get the point. So I'm going to need to literally walk the entire distance across the row until I either count to 4 for the same color checker in a row, or I run out of columns. Does that make sense? So let's write this just for the bottom column. Okay? Rather than adding the complexity of having a loop inside of a loop, let's just do this for the very, very bottom column. So here, I'm actually going to write this above the check for vertical winner. I'm going to say check for horizontal winner. And we're just going to check column or row, I would guess that would be row length minus 1. Okay? So we're going to say int cur row is equal to this dot the grid dot length minus 1. Okay? So what does that give us? That gives us, if this is the grid, this is 0, 1, 2, 3, 4, 5. Length is 6. 6 minus 1 is 5, so I'm dealing with row 5. Okay? Now, for each column, for int I is equal to 0, I is less than the grid at bucket 0 dot length, I plus plus. Okay, so this says for every single column, check cur row. So we're going to go ahead, we're going to set count equal to 0 because I haven't found any in a row yet. Now, is there anything that says I can't go ahead and waste my time by checking all the way across? If logic would say, if I'm right here and count is currently 0, I don't need to check the next one. There's no way I'm getting 4 out of this, right? But does anything say that we can't just go ahead and check it verbosely, check the entire row, and then check our count at the end of that row? Might as well do the count. Especially since it's not us doing the work, it's the computer doing the work, right? So we're going to check this entire row. We're going to say, we're going to need our last checker as well. So last checker will start off as null. So notice that these 2 lines of code here are basically identical. Well, they are identical to what we wrote at the very beginning of our loop before. All right, we're checking for a horizontal winner here. So if last checker is equal to null, that is, if this is the first checker we ran into, then what am I going to do? Well, then I'm going to increment count. But only if I'm even looking at a checker. Okay? If I just hit this and I get to right here, I don't want to increment anything because just because I found a blank, one blank in a row is not going to cut it. So I want to ask if the grid at bucket cur row I. So if the grid at bucket cur row and cur column is an instance of checker and. So if that's true, if I'm looking at a checker and last checker is null, then go ahead and set last checker equal to the checker we just ran into. And set count plus plus. Else, if I'm looking at a checker, but last checker was not equal to null. So if I'm looking at a checker and the checker I'm looking at is the same color as the last checker I ran into, then we want to do something. Right? Now, all of these are based on whether or not I'm currently looking at a checker. Because if I'm not looking at a checker, I'm going to zero count back out. Correct? Because that means I ran into no checker. That means everything else is not in a row. So I'm going to change up this if statement a little bit. I'm going to break it into multiple pieces. So my first if is going to be if I'm looking at a checker. That's all I'm going to ask. If I'm currently looking at a checker, let's do something. If I'm not currently looking at a checker, set count equal to 0, set last checker equal to null. Reset things. Okay? So if I'm in this else, that means that the current row column I'm looking at is not a checker. But if it is a checker, then I have some work to do. If last checker is equal to null, that is, this is the first checker I've run into, then we're going to say count plus plus. Else, if last checker is not equal to null, then I need to ask the question. I need to say, hey, the checker I know I'm looking at a checker. How do I know? I would not be in this if statement if I was not looking at a checker. So if I'm currently looking at a checker, I want to know, is it the same color as the checker I looked at last time? That make sense? So else, if, and here we'll do it up at this level. The current checker is an instance of red checker and last checker was an instance of red checker. So if either of those things, if those two things are true, or they were both black checkers. So if they were both red checkers or they're both black checkers, then what am I going to do? I'm going to say count. Actually, I'm going to do this. It doesn't really matter. That's fine. I'll just leave it. So if they're both red checkers or they're both black checkers, that means I just found another one. Correct? Count plus plus. Else, I'm looking at a checker, but it's not 2 in a row. I'll set count equal to 1. I am looking at a checker, but it's a new beginning of a potential winner. That makes sense? Okay. That's as long as I'm looking at a checker. If I'm not looking at a checker, start the count over, reset last checker. So this should work for checking just the bottom row. Now, do I always want to check the bottom row first? Probably, because that's where we start filling the thing up from. But in order to check for horizontals the way we're doing it right now, we're going to check verbosely the entire grid. So we're going to walk from the bottom row up to the top row. So inside here, inside this loop, I'm going for each column in the current row, where the current row is called cur row. And I'm setting cur row equal to the last legal row. I'm going to write a loop outside of this that changes cur row around. So I'm going to say for int cur row is equal to this dot the grid dot length minus 1. Keep going as long as cur row is greater than or equal to 0. Cur row minus minus each time through. So I wrote it generically first with a hard-coded cur row. But now I'm going to make cur row my counter in my loop here. So I put the whole inside loop, this whole loop, what does this guy do? We could say that this whole inside loop checks all columns in current row. The outside loop checks all rows starting with bottom row and working towards top. That's what that outer loop does. So all this crap here is going to live inside of that outer loop that goes through all the rows. So I'll put this closing curly brace there. I'll highlight everything that's in that loop. So I'll highlight those two loops to fix my indentation. If you're on a PC, you can hit Control-I. If you're on a Mac, hit Command-I, and it'll fix the indentation. So I wrote this generically by creating just my looping structure for checking one row. And then I wrote the loop that takes those rows through the journey of all the rows. Okay, now right outside of the outer loop, right outside the inner loop, I need to ask the question, did I just find a winner? How will I know if I found a winner? If count is equal to 4. If count is equal to 4, I want to return true. So I'll just steal the code from right there. Come up here to our right after our inner for loop. If count is equal to 4, return true. Now, if I'm looking at a checker, so we're back inside our inner loop here. If I'm looking at a checker, whether the last checker was null, or I'm counting something, or I'm starting over, under any of those circumstances, I need to set my last checker to the current checker after I make those decisions. That way, the next time through, my last checker will be this checker. So I'll say last checker is equal to the grid. Well, I'll just steal this right here. At cur row I. So after I ask the questions, after I do all my logic and adjust count appropriately, then I'm going to overwrite last checker with the checker I just looked at. So we have our new last checker for the next time through. That makes sense? So now our code should check for a horizontal winner. It should also check for a vertical winner. So we should have two different ways of winning right now.
Can you scroll back up to the end of horizontal? Where exactly is, wait. So
Here's the horizontal check.
So the if, scroll down a little, so that's right before the last, okay. Yeah.
This is right before the closing curly brace of the outer for loop.
Yeah, so I was checking.
So we'll go ahead and run this. And let's go ahead and test it for a horizontal winner. So we'll do 0, 0, 1, 1, 2, 2, 3, 3. And did we get a winner? We did not get a winner. Why isn't there a winner? Oh, I need to make sure I set my count. I need to zero out count and zero out last checker outside of my inner loop, but inside my outer loop. We didn't write the loop the first time through. That's why we had it just sitting up there. So for each row I'm going to check, what am I going to do? I'm going to start my count off at 0 and say I have never found a checker. Then we're going to check all the columns in that row. All right, we've written something stupid here. Hold on. Count of 0, last checker. This is going to, so for current row, the very first time we'll start off at the very last row, the bottom row. Oh, sorry. Oh, no, that's fine. That's correct. As long as it's greater than or equal to 0, that's fine. Minus, minus, okay. This is going to start at column 0, go all the way to, but not including the length of the final column. So this will go through all the columns. At each column, if I'm looking at a checker, then if last checker is null, just say count. We can really say count is equal to 1, but count plus plus should not hurt anything. So if I do not currently have a last checker, I just found somebody. Count equals 1. Else if my current checker, that is the checker at row, cur row, and column I is an instance of red checker, and my last checker was an instance of red checker, if that was true, or my cur row, cur column was an instance of black checker, and the last checker was an instance of black checker, then we'll say count plus plus. Else, I must have found a new first checker. So I'll set count equal to 1. So count is either getting set to 1 or it's incrementing by 1 as long as I'm looking at a checker. I'm either at the very beginning of a new possible connect for, or I'm somewhere in the middle of an existing connect for. If I'm in the middle, I'm right here. Otherwise, I'm either at the very first place or I'm looking at something that did not fit into this category.
If you put the if count equals 4 in the inside for loop instead of the outside one, that works.
If I do...
Scroll down. The if, move it inside a curly brace. Or
Right, hold on a second. So this goes through each. Well, it should not. So this inner loop checks all the columns. So at the end of those columns, oh, she's right. The question is why? Let me show you this example. Right now I have 4 in a row, right? And it just checked. Now, it's going to, as it's checking, so if this is the current state of the board, it's going to say, oh, count is 0, count is now 1, count is now 2, count is now 3, count is now 4. Oh, I ran into something that's not a checker. If I run into something that's not a checker, what do? If I run into something that's not a checker, I set count equal to 0. I set last checker equal to null. Does that make sense? So I'm shooting myself in the foot. Even though I found 4 in a row, as soon as I look at the 5th one, because I'm not going to stop until I'm done with the entire column, I'm resetting count back to 0, even though I already found a winner. So by moving this check, count is equal to 4, inside of this loop, each time through that particular row, as I'm going through that row, I'll check. Have I found 4 yet? 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 To keep myself from accidentally zeroing back out my count. Does that make sense? So now this should work for it. There's your winner. Okay, so that does horizontal. So now we have vertical, we have horizontal. How would we handle diagonal?
Nice question. Let's take that out of the rules of Connect 4.
Huh?
I said, nice question. Let's just take that out of the rules.
Take out of the rules of Connect 4. Can we envision that checking diagonals is going to start getting tedious? Because going down the path we're currently going down, what are we going to have to do? We're going to have to go through every single row and column and find out if the particular row and column we're looking at right now is involved in a diagonal winner. What does that mean? That the guy up 1 over 1 from him is the same color as him. The guy up 1 over 1 from him is the same guy as him. The guy up 1 over 1 from him is the same guy as him. Or the guy up 1 over 1 is the same guy as him. The guy up 1 over 1 is the same guy as him. The guy down 1 over 1 is the same guy as him. Verbose over and over and over and over again. Make sense? Okay, well. We simply can't have that. So we're going to take all of our beautiful code here. And how much code was that? So that started off on line 14 and ended on 94. 80 lines of code. Gone. See, look how much cleaner his winner is now. Okay, so do we need to check the entire board to see if the current state of the board represents a winning? When you're playing Connect 4 with a friend or something like that, after you make a move, do you check the entire board to see if there's a win? Or do you just check the checkers involved around the move you just made? If I just made a move, and if we assume that we're always following this, where we're always checking for a winner based on the move we just made, and there wasn't a move before, the only way we can possibly have a winner now is if the move I just made caused me to win. Right? That's true. That's a true statement. But still, it's better off than we were doing before, right? We could certainly count and say, well, we haven't made at least 4 moves. Well, we haven't made at least 8 moves total. 7. Somebody will make their 4th move before the other person. So if we haven't made at least 7 moves total, we can't have a winner. So we can certainly throw that efficiency in there. But even if we just forget about that for a second and just say, I only need to check the last move made to see if he is involved in a vertical win, or a horizontal win, or a diagonal win. Does that make sense? If it's a vertical win, I only need to check from the guy down. Correct? I know there's no checkers above him. That defies the gravity and the rules of Connect 4. Right? If I just made my move, I dropped into column 3, I know there's not a checker above me. Does that make sense? So for a vertical check, if I know the column the last move was dropped into, I can more easily check for a winner, and I don't have to check the entire board. So let's think about this. Right now, when we drop a checker, dropping a checker is returning a Boolean. Right? When it returns a Boolean false, that means that a move was not made. But when we return a true, we know that a move was just made. And we also know what checker we just put there, don't we? I can create a couple of global variables here. Private int last call, private checker last checker. So I'll have 2 private fields associated with a board. A board will always be aware of the last checker that actually was placed onto the board, as well as which column it was dropped onto. That might be helpful information for us, right? Especially when we check for a winner. So, inside of drop checker, before we return true, which is the only time when a checker was actually placed, I want to say this dot last checker is equal to C. That's the checker we just dropped onto the board. Where did we drop it? We dropped it this dot last call is equal to call. The column we dropped him onto. That make sense? So now, whenever we drop a checker successfully, we're not setting those things up for an unsuccessful drop. We're only setting it up when we successfully add a checker to our board. We're keeping track of the traits about that move. So now inside is winner. When we check for a vertical win, I only need to look at the column associated with the checker that was last dropped, which will be 0 through 6. Correct? And I know it's a legal column because we wouldn't have let them drop the checker if it wasn't. Right? We know the nature of our drop checker method. So to check for a vertical winner, given the last checker, what do I need to do? Well, I need to go to the bottom of that column, walk my way up and count. What did I do by this? I no longer have to have a loop inside of a loop. I don't need to check the whole board. I know exactly which column I'm dealing with. Correct? That might have a winner. So we're going to say for int row. It'd be a little bit easier if I name my variables rows and columns instead of i's and j's for this example. So for int row, we'll start at the very, very bottom. So I'll say this dot the grid dot length -1. That's the last legal row. Keep going as long as row is greater than or equal to 0. Row minus minus. So we'll potentially go all the way. Actually, we don't even need to do that. Do we even need to go all the way up? We certainly could do it this way. I'm just saying, is there an actual easier way of doing it even than this? I can go to my last checker.
What are you trying to say? Like, you're trying to say that each time you drop it in a column, that column gets a value of how many checkers are in it, and then I don't really know what you're saying. And then this one, you'll know that it only has X number of checkers, so you only have to go up to
Well, I only need to think about whether or not the checker that I just made a move with, whether that guy is involved in a vertical win. I don't have to check to see if a vertical win exists anywhere in this column. I know if it exists in this column, it will involve the guy that just made the move. I know that for a fact. I also know for a fact that the guy that just made a move will also be the top checker in this column. Correct?
Okay.
So really, I just need to go down, start at the top of the column and go down until I hit the checker that the last move was made for. And then from him, walk to the bottom and see if I count 4. Does that make sense?
Yeah.
So we're only dealing with that.
So
Now,
you're trying to make easier.
well, what I'm doing with this loop is I'm saying let's go to the very, very, very bottom row and walk our way up. That's not where we're going to find that checker. I think what will be beneficial here, at the very beginning of his winner, in fact, we're going to add another field. This will make it easy. Private int last row. We're going to get the exact row and column where our last checker was placed. Because we already have that information. Drop checker got that information for us. So if we look at drop checker, what column did we set it in? Or what row rather? Row I. We put that checker at the grid, row I, column call. So I'll say this dot last row is equal to I. So now I know exactly where on the grid the checker that I just made my move with is. I know exactly where that guy is. Vertical winner? Now, the only way there can even possibly be a vertical winner is if the row is greater than or equal to what? If we run this, I currently have a, oh here, let me just return false for right now. If this is the column, well, let's say I'm dealing with column 2. The only way I can possibly have a winner in column 2 is if the last checker's row is 0, 1, 2. Right? 3, 4, 5. So if the last guy's column is 5, or sorry, row is 5, I cannot have a winner. Not enough checkers in that column. If it's 4, can't have a winner. Not enough checkers in that column. 3, can't have a winner. Not enough checkers in that column. 2, the only way it could possibly have a winner, vertical winner in this column, is if its row position is 2 or less. Correct? So for vertical winner, I can say if this dot last row is greater than, well, actually, let's do this, is less than or equal to 2, we might have a winner. That's the only circumstance that we could possibly have a vertical winner associated with that last move. If his position is in row 2, 1, or 0. Okay? Now, how do we know that we had a winner? A vertical winner associated with that guy? We have a vertical winner associated with that guy if his current color, the guy right below him, the guy right below him, and the guy right below him are all the same color checker. Does that make sense? I don't even need a loop. I can just check those 4 checkers. So we're going to create a Boolean W. Here, let's just call it Boolean answer. We'll start off as false. So we're going to say if.
Typo in the word.
Oh, thanks. We're going to say if this dot last checker is an instance of red checker and this dot, actually let's do this dot the grid at bucket row plus 1 call is an instance of red checker. And
I'd rather use the loop.
well, this will actually be much cleaner. You'll see the final version of this. Row plus 2 is an instance of red checker. And row plus 3 is an instance of red checker. And they're not called row, it's called last row and last call. This is last row. And last call. If that's true, if they're all red checkers, then answer will be equal to true. Do we even need to keep track of answer? Can we just return true? We have a winner. Let's just return true. I don't think we need this answer thing. Assuming we know the last row and the last column of the last move made, if all the checkers below that guy are the same color, return true if they're all black. Else if they're all black, so if they're all red or they're all black, return true. Otherwise, we're still kicking. We do not have a winner yet. That's our entire check for vertical winners. Make sense? Now, let's check for horizontal winners. Just return something there so I can run it. For a horizontal winner, what needs to be true? Well, I know if I'm dealing with, if my column is 0, I'm not going to be checking the guys -1, -2, -3. So I can only go back from where I am all the way to 0, or forward from where I am all the way to 6. I can't go beyond that. So if my current number is, let's say it's row 3, how do I know where to check to see if this guy is involved in a Connect 4? I could be the last one. I could be the first one. I could be somewhere in the middle. How would I do this check? Couldn't I start where I'm currently at and try to go as far as I can this way, counting how many things I run into that are the same color as me, and then go as far as I can the other way, counting how many guys in a row I find that are the same color as me, and if those two numbers added together are 4, I have a winner? I'm only involving myself. So the second I hit a color on one of my sides that's not me, I'm done going in that direction. I'm not resetting the count or anything. I'm saying, okay, well, I went to my left one, not the same. If there's a winner involved here, they're all to the right. Does that make sense? So for checking to see if we have a horizontal winner, we're going to have count is equal to 0. And we're going to try to go all the way to the left, finding guys that are the same color as me. So for int call is equal to last call. Keep going as long as call is greater than or equal to 0. Call minus minus. So we'll potentially go all the way to the left as far as we can go. Okay? Now, we actually know that we count as 1. Correct? I already found one of myself in a row. It's myself. So can't I actually start count off at 1? I already found 1. And then start call off at last call minus 1. Let's check all the guys to my left to see if they're the same color as me. Let's check all the guys to my right to see if they're the same color as me. So we're going to start count off at 1, and we're going to keep going checking left, and as long as they're the same color as I am. So if this dot the grid at bucket last row col is an instance of red checker, and this dot last checker is an instance of red checker. If that's a true statement, if the checker that I last placed was a red checker and the checker I'm currently looking at was a red checker, then what am I going to do? I'm going to say count plus plus. Else if they were both black checkers, count plus plus. Else, if they weren't both red checkers or they weren't both black checkers, then they were different color checkers. Correct? And if they're different color checkers, I'm done going in this particular direction. That make sense? So I'll break. Get out of this loop. And let's go the other direction. The other direction says for int col is equal to last col plus 1. Keep going as long as col is less than this dot the grid at bucket 0 dot length, so the total number of columns, col plus plus. Now remember, for loops are pre-check loops. So in the event that col was actually the last legal column to begin with, there's no guarantee we will pass this test the very first time. So we don't have to worry about accidentally walking off the end of it. This loop controls it. All right, so trying to go to the right now, we're going to ask the same exact question. So after both of those loops, if count is greater than or equal to 4, we actually could just say is count equal to 4. Because we know it won't be greater than 4. Why? Because we're checking for a winner after each move. That make sense? But we could say greater than or equal to 4 if it makes us feel better. It's not going to break anything. So if count is greater than or equal to 4, return true. We have a winner. That's how we check for horizontal winners. Vertical winners, real easy. We know the winner would be immediately below me. Horizontal winners, a little more difficult because we don't know where in the range that we are the winner, right? We just know that if there's a winner, we are part of it. This current checker is part of it. Now, what about diagonal winners? I can either win up and to the left, down and to the right, or I can win up and to the right, down and to the left. Correct? Can't I do a pretty similar thing with loops? To walk up and to the left and count, down and to the right and count? See if that's 4. Otherwise, go up and to the right, down and to the left. See if that's 4. If any of those are 4, I have a winner. Otherwise, No winner on this board. Diagonal winners. We'll go ahead and we'll repurpose count. So we'll start count off at 1. Because we're going to go ahead and count ourselves right off the bat. Then we're going to check everything. Let's go up and to the left. So up and to the left means that the column so for int row is equal to last row minus 1. I want to give you 2 variables. Yeah, this would be a good time to show you this. I'm going to put a comma in here. I'm going to say col is equal to last col minus 1. So I'm going up. So I am subtracting 1 from the row. So if I'm currently at row 5, I'm going to go to row 4, last row minus 1. If I'm currently at column 3, I'm going to go column 2. So up, over. All right? But notice for this for loop, I'm setting 2 separate variables as my counter, dividing them by commas. Next comes my Boolean expression.
Do you want to put int in front of call as well, or just?
You don't have to. Actually, I don't think it's correct to put an int in front of it. Yeah, it's not correct. They all have to be integers in order to use this syntax. Okay. So I'm creating 2 separate variables here, a row and a column, and giving them their initial values. I want to keep going as long as col is greater than or equal to 0. So I don't want to shift too far to the left that I go off the grid. And row is greater than or equal to 0. I don't want to go too far up that I'm off the beginning of the row. So as long as both of those things are true, what am I going to do each time? I'm going to say row minus minus, comma, col minus minus. So it seems complex, but this is the exact same for loop we've been writing all the time, except now we're having it control 2 variables. We're having it change rows and columns. And this protects us from going off the end of one row or off the beginning of the column. Does that make sense? So even if we run out of rows, but not columns, this will stop, because this Boolean expression is an AND. I have to be currently looking at a legal row and a legal column in order for me to check anything. Make sense? So if I'm here, then what am I going to do? I'm going to ask the same question I asked up here. Well, pretty much the same question as I asked up here. Small little change. If the grid at row col is an instance of red checker, and last checker is an instance of red checker, count plus plus, else if the grid at row col is an instance of black checker, and this last checker was an instance of black checker, col plus plus, else break out of this loop. So we'll go as far as we can up and left. So we'll say up and left is that first loop. Now the second half of that diagonal win would be down and right. Correct? So we're going to start at last row plus 1, down 1 row, last col plus 1, over 1 column, down and right. Keep going as long as col is less than this dot the grid at bucket 0 dot length. I'll take the this dot the grid off. I'll just say the grid just to save a little space there. The grid dot at bucket 0 dot length, so the number of columns. So make sure we don't go off the end of the columns. And row is less than the grid dot length. And each time we'll increment row and increment column.
Why is that less than the grid at 0 dot length and the row is just the grid dot length?
This says row 0, the number of columns in that row. This other one just says the number of rows in my grid. That make sense?
Yeah, can you just scroll so I can see that? Alright, thanks.
Okay, so then we're going to ask the exact same set of questions we asked before. Count plus plus. Okay, didn't change the questions at all. The only thing we changed is the loop took row and column on a little bit different voyage. The first loop went up and left, my left. The second one went down and right. Actually, it should be both of ours, right? Up and left, down. Yeah, we're good. Okay. So at the end of those two loops, we can then ask the question, if count is greater than or equal to 4, return true. We had a diagonal winner. We didn't have a diagonal winner yet. Now we need to check the other direction, the other diagonal. So I'll copy all that code. I kind of put a big gap in here just so we can make sure we tell the two of them apart. I'll close the gap here in a few minutes, just so I don't accidentally mix the two together. So I pasted that in there. So we know this is the next part. So instead of going up and left, now we're going to go up and right. So we're going the other diagonal. So up and right says row will go up, but column will be last column plus 1. So row is going up, column is going over. Row is shrinking, column is growing. Keep going as long as col is less than the grid at bucket 0 dot length. And row is greater than or equal to 0. Each time we'll subtract 1 from row, and we will add 1 to column. This is going up and over. Yep.
Since we're putting the same, if the grid, row, col, if we're putting that the same thing in each one, can't we just turn that into a little method somewhere else and then just toss it in?
Absolutely could. 5 minutes ahead of us, aren't we?
Sorry.
No, that's perfect. That's absolutely what you should be coming up with. We're repeating a lot of code here, aren't we?
Yeah.
What's a method? It's a reusable chunk of code. Make sense? So let's finish writing it this way, and then we're going to compartmentalize that stuff in the method. We'll see how much this shrinks up. Okay, so this loop just takes row and column on a voyage. Like she pointed out, we're asking the same stupid questions every time. Adding up count. Next one, so this goes up and to the right. This one's going to go down and to the left. So what does that mean? We're going to say row is last row plus 1. That goes down. What this used to say. Oh, I didn't change the comment up there. That's why. That one went down to the right, down to the left. This one went up to the left and down to the right. I'm just updating the comments, none of the code. So this one's going to go up to the right, and this one's going to go down to the left. So that means row will be last row plus 1, same as it was before. But col will be column minus 1. Keep going as long as col is greater than or equal to 0. And row is less than the grid dot length. Make sense?
Col minus minus.
Yep. Col minus minus. And then once again, asking the same questions. So what she wants to do, she wants to take this code in here. I'm just going to grab all of it for right now and put it inside of a method. So we'll go right before is winner. And we'll make a little private method, Boolean is match. And is match will take in a row and a col, those two variable names. I made sure I named them row and col because that's the same name of the thing I'm about to paste in. So I'll paste some code in here. If I have a match, I'm going to return true. If I have a match, return true. Otherwise, return false. That make sense? All this method does is takes a row and a column and it returns true if the checker at that row and column has the same color as the last checker that moved. Okay? And that's just called isMatch. So then what we can do down here, we can ask the question. We can say if this dot isMatch row col, if that's true, count plus plus. Else break. So that giant if statement got replaced with just this. So for as long as I have matches, count plus plus, then break. For as long as I have matches, count plus plus, then break. Did I have a winner? If yes, return true. Otherwise, I can close the gap now. Set count back to 1, because we're already counting ourselves. Then, for as long as I have matches, count plus plus. For as long as I have matches, count plus plus. If I had a winner, return true. Otherwise, I have checked vertical, horizontal, and diagonal for the last move and did not find a winner. So it's a giant minefield. I make a move, then I check, is there a winner? What do? We check for horizontals, then we check for verticals, then we check for one of the diagonals, we check for the other diagonal. And if I never return true anywhere in there, I'll return false at the very bottom. No winner found.
So why in the diagonal, like before we had to put the if count is greater than or equal to 4, we had to put it inside that for statement. So why are we putting it outside of it now? Like that one.
Well, because these two work hand to hand. These two for statements, this checks up and right, this checks down and left. Those two put together gives us a total count. Because we don't know where we are in the middle of that diagonal. Okay, so that is winner for our board. Now, what's interesting here there's these little things like minimizing stuff, just like on an operating system. So one of the benefits of object-oriented programming, so it's one of the things you considered in your paper due today, is encapsulation. The details are hidden from us. Right now we're looking inside the object. Doesn't this look pretty simple once we hide all of the nasty code that did all this stuff? What we're looking at right here is equivalent to what a header file looks like in some older languages. Let me show you that real quick. This doesn't exist anymore in Java, so I'm going to go ahead. I took a team of students to Iowa this weekend to a programming competition. And just to give you an idea here, we're writing some iPhone app stuff.
What was your app?
This is the one I wrote was for it was a NS object-based API for the Dice.com RESTful API. Fairly complex stuff, but basically it did job searching. It used Dice.com's job search API, and it pulled down jobs so that when I run this, I can go in and I can say, show me all the jobs in, so this will pop up. So let's say I'm looking for jobs in Milwaukee. So I hit search, and it's going to go out, hit the internet, and find all the Milwaukee-based jobs. So here's a senior project assistant. Now they're actually returned 2 pages of jobs, so I can hit it a second time. Here's another project manager, company called IT staff, blah, blah, blah. Just pulls in a bunch of information. So I wrote a tool that talks to their API. Now, more importantly for our little example here, just look, which one am I looking at? I'm looking at Dice job right now. So here is a class with a bunch of details and crap in it, right? Lots of complexity, okay? Not any more or less than really our Connect 4. Our Connect 4 has, every hard program is made up of a bunch of easy parts. You spin through here, here's an if statement. Here's an else if. I bet you anything we find some loops in here. Let's see. Yeah, it's all basically just else ifs inside that guy. Yeah, see, it's even easier. I don't even have loops. I think there's loops in this one. Yeah, here's a loop. This is a for loop. This is a for each loop in Objective-C. We learned about a for each loop today in Java. Instead of a colon in Objective-C, it uses the word in. So for every NS dictionary called a job inside of this thing called D. Give me something. Okay, but now the thing I want to show you here though. So here's the details of diceapi.m, this file I wrote. That's not dissimilar to the details that we're seeing inside of board that we just wrote. This guy right here, right? Now, older languages or languages more closely based on C++, like or more closely based on C, like Objective-C is. See at the top here, this guy imports diceapi.h. It imports a header file. If I show you that diceapi.h, see how it looks pretty similar to my version of board here with everything minimized? This guy shows you all the crap that diceapi will do. Here's all the methods that it has. You will find the details over here. This is all of those guys implemented. Does that make sense? So we've gone away from this idea of header files. Historically, header files are kind of an older concept. I think they're a very useful concept. In fact, Objective-C, this is this is the iPhone programming language, it does not require you to use header files, but just about every Objective-C programmer does. Just about every one of them. I mean, at a glance, you can find out what diceapi does by just looking at this. It holds on to these pieces of information, total pages, current page, total jobs found, blah, blah, blah. I can create it with an API key. I can get jobs with a query. I can get recommended jobs with a job ID. I can get the next page, the previous page, and then I have getter methods for getting my total pages, current page, and total jobs found. Those are all the magic tricks that object knows how to do. In a completely foreign language to us, but we see that, and this is something that solves a hard problem, harder than the Connect 4 problem, right? But all hard problems are made up of a bunch of easy parts. It's all the same crap in here. What's an NS dictionary? Who cares? I guarantee it's not any harder or more complex than a big integer. We've used those, right? Didn't you say your guy had you write your own big integer class? Whoa. No wonder you didn't have fun. All right, so that's kind of just showing you the header file stuff. So after I minimized everything that was inside board, we see that we're kind of left with the equivalence of what's in a header file. All right, so what does board do? We can drop a checker. A board can display itself. We can ask a board if there's a winner. And we have a little private method in here called isMatch, which encapsulated the same questions we were asking over and over and over and over again. And Lauren said that, hey, why don't we throw that in a method? Because that's what methods are for. Reusable chunks of code, right? Perfect use for a method. I'll go back into driver here. So let's finish this up. So we have our idea of a game object. So what does a game do? We create a game. It reads in the player name and that kind of stuff, even though I don't think we ever use the player name. We give them a bunch of checkers. Then we tell a game to start. The game starts. We say, while the board does not have a winner. As long as there's not a winner, display the board, tell player 1 to enter their column, read it in, do that until they finally give us a legal column. But then we need to check for a winner, correct? Right now, we're letting 2 players go in a row without checking for a winner. We really need to toggle back and forth between those 2 players. That way, we can determine who won. So as it stands right now, our game should accurately declare winners, that there was a winner. So if we go ahead and let's just do a vertical winner real quick.
Looking at this, it looks like last time after class must have gotten impatient because I already fixed it up with humans and stuff.
Oh, did you? Oops. So we had a winner here. Must have been because player 2 made their last move, so it read it in before it displayed the board the next time. Like, we read in the winner before we had a chance to ask for another one where we displayed the full board. There definitely is another R here. Okay, so we have horizontal. Do we have vertical? Oh, I'm sorry, we have vertical. Let's check horizontal. 0, 0, 1, 1, 2, 2. Oh, that's not going to work. 1, 1, 2, 2, 3, 3, 4. There we go. So we have our horizontal winner. And then let's check a diagonal winner. Diagonal is going to be a lot harder to... Let's do 0, 1, 0, 2, 1, 2, 2, 3, 3, okay, so the very next move we should have a winner. Right, but it's because we're doing 2 moves in a row. So now it tells us we had the winner. We had the winner, but it doesn't check until after it's let both players go. Okay, so it seems to be accurately checking our diagonals. Let's do the other diagonal just to make sure. So we'll do 6, 5, 5, 4, 3, 4, 4, 3, so next one should show the winner. Uh-oh. Ruh-roh. All right, we messed up our up left, down right diagonal. Let's go into is winner. Up left, down right. Oh, our original one. Okay. So row is equal to last row minus 1. Col is equal to last col minus 1. Keep going as long as col is greater than or equal to 0 and row is greater than or equal to 0. Row minus minus, col minus minus. I think that part sounds right. Down and to the right. Row, last row plus 1. Col, last row plus 1. Col is less than the length. Row is less than the length. Row plus plus, col plus plus. That looks like it should work.
Is count going back to 1 after it breaks out of the for loop or no?
Yeah, we set it to 1 right here, right
yeah,
before.
But after it goes through the first for loop, is it resetting to 1?
We don't want it to.
I know, but is it?
No.
Maybe that's the problem.
No, it's not. Here, let me just run this again. Let's just make sure I didn't make a stupid. Let's make sure I actually did have well, no, it was pretty clear there was a winner, right? Okay, we definitely have a winner here. So the last move I made here, it's checking everything up to the left. And not finding anything there the very first time. Oh.
Mine works. Well, no, wait, just kidding. It works up and right.
Yeah, mine works up and right as well. Let me look at is match here real quick. That looks like it should be right there. Up and left. Last row should be whatever the current row is, -1. 0. Down and right, last row +1. Down a row. Oh, down and right column is also +1. Keep going as long as column is less than the grid at bucket 0.length and row is less than the grid dot length. Increment row, increment column.
No, when it goes up and right and then down and left, if you make it like, if you bring it up, so it's not just going from the bottom row and counting, if you bring it up one, then it doesn't work either. Do you want to see the board?
Oh, you mean the other angle, the other diagonal?
If you go like the diagonal up and right / down left, but like you don't, but like, can I bring this over and show you?
Yeah. So you're saying that that one's broken too?
Sort of.
So whatever's broken on one of them is probably broken on the other one. So there's got to be some special case that we're not taking into account.
Yeah. See this one, black, 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 but it doesn't count because it didn't start on the bottom row. But when I did it the first time and it started black, black, and it started from the bottom row going up 4, then it works.
Okay.
So when we go up, so when we don't start on the bottom row, then it doesn't quite get it.
Don't start on the bottom
I don't know
row.
why.
Let me check something here real quick. Okay, we did it 0 based. That's fine. Just out of curiosity here, let me... Okay. So it does seem to involve that bottom row, because I just did a horizontal that's failing the check too, when we have a winner on not the bottom row. So why is the bottom row breaking? It's because we're seeing the row was... That's for horizontal winner. So we're going to start at the current column. Well, start to the left on the current row. Keep going as long as we're greater than or equal to 0. So potentially going all the way to the left. Each time asking, is the last row we made a move on at bucket column, is that a red checker? And is the last checker a red checker? If both of those are true, count plus plus. Else if it's a black checker, and the last checker was a black checker, count plus plus, else break. Okay, it has to do, it's got to be with our drop checker. Our code in there looks fine. So I'm doing something dumb related to drop checker when we set that row. I is getting set to I, or last row is getting set to I. The row that we placed that checker. Okay, so we saw it break on horizontal winners. So when my last move was row equals 4, column 4. Let's think about that. So count is equal to 1. Call is equal to 3. So we'll go everything to the left of that. Keep going as long as call is greater than or equal to 0. All right. I'm going to show you how the debugger works. I think that'll be the best way for us to look at this. So whenever you have an issue like this, where you have a fairly complex program going on and something is zigging when it should be zagging, we're going to go ahead and I'm going to hit this little bug looking guy here. Well, actually, it's already running. So since it's already running, we can just go up here to the upper right where it says debug. We can click on this. And this puts us into the debugger. So I'm going to come into my code over here, and I think you should just be able to right-click, toggle breakpoint. All right, so I'm going to start my winner check. Well, what I did is I just turned a breakpoint on inside my code at this very first if statement inside of his winner. In fact, actually, I don't even want it there. Let's just work with just the horizontal one, because I'm pretty sure if we figure out what the problem is with horizontal check, it'll fix our problem with the other ones. It's got to be something dumb we're doing. So what breakpoint says is our program's going to run up until this point, and then it's going to stop, and it's going to let us walk through it one line at a time. So I'm going to go ahead and hit play. So our program has started. I'll enter, let's do 3. We're going to do a horizontal thing. That does not win on the first row. So I think we proved that it works when it's on the first row. Why isn't... There we go. So I'm going to make my move on 3, and then I'll make, before it'll check to see if there's a winner, going to have to make another move. So I'll do 4. Now it's checking to see if there's a winner. We know there won't be this time. So I'm just going to hit the play button again here, and that'll just skip it past this time. There shouldn't be a winner. Then I'm going to do 5, 2, skip it through again. Okay, now I'm going to try to create a winner on this second row. And the last time through, we're going to go ahead and we're going to walk through one line at a time. I'll show you how the debugger works. So we're going to make the move 0, 1, we're going to do 2, so we're going to have red win. Run it through. So 3. 4. Okay. And then one last one. 5. Okay, and I'll put this at 2. That's fine. Okay. Now, we definitely have a winner represented on our board right now, correct? So it's going to go through, so we stopped at our breakpoint for horizontal winners. So we're going to start at count is equal to 1. Up top here, we have several different things. We have step into, we have step over, we have step return. You will almost always use step over. Step over lets us go one line at a time. So I'm going to click step over. That kicks us down to here. We should be able to hover over these. It should tell us what the different values are. So last call is equal to 1. So last call minus 1 will be 0. Oh, this will work. Can anybody tell me why this isn't working right now? The thing we spent the last half hour doing was all based on what was the last move made, to see if there was a winner involved in the last move made. Aren't I kind of sometimes letting the second guy make... Isn't there sometimes a winner and then I let somebody else go again before I check?
Technically then, but it should work on mine then, because I separated it already into who goes next and stuff. I separated, so then mine should work. Do you want to see my code?
Well, let me try this real quick on mine first.
Because I separated mine so that after the first player takes their first turn and the second player takes their turn, then it's all separated.
So I'm going to go into game.
Yeah.
And we are going to... I'm just going to change this to wild true. This would be a good use for an infinite loop. You probably will not hear many people say that there's ever a good use for infinite loops. But I'm going to basically play this game forever. That is, forever until I break. Until I leave the loop. Okay? So, while true, we'll let our player make a move. Then we'll ask if the board dot is winner system.out.println player 1 wins. And then I'll break to get us out of this infinite loop. Similarly, we have player 2 can win down there. We'll break out of the loop. So now we're going to check each time through. But I check for the winner after each individual move, which means I should be looking in the right place for there to be a winner. Does that make sense? Before I was potentially looking over here when the winning guy was actually here. All right. Now, we're going to go 2, 3, 4, 5, then 2, 0, 3, 1, 4, 0, 5. There's our winner. So it works for horizontal, not on row 1, or not on row 0. So that one looks fixed. So I suspect the other ones will be fixed as well. So let's do 6, 5, 5, 4, 3, 4, 4, 3, 2, 3, 3. Winner. All right. I think it's working now. The code we wrote was fine. It was a bug we had from last class that was causing the issue. Well, not really a bug. It was an incompatibility between our updated way of checking for a winner compared to our way that we were looking for a compared to the way we were making moves last time. Last time we were allowing to make a move followed by another move, then we checked for a winner. When we changed our check for a winner to look only at the last move made, we kind of shot ourselves in the foot because we sometimes let the guy who lost make another move. Make sense? Okay. Well, that was an interesting adventure. So, questions about any of that? So let's talk about our final programming assignment. Final assignment, which I will give you 2 weeks to work on, since next week's technically spring break, even though we technically have the grad class next week, which is weird. So basically what I'm going to tell you is whenever you submit it, email me letting me know that you submitted it, and then I'll go and grade it and record your final grade. Make sense? So I'm going to say you have 2 weeks, but the reality is if you emailed me in 3 weeks, I probably wouldn't say anything. If that makes any sort of sense to anybody. Sooner you do it, the sooner you'll get your grade, is what it boils down to. So, final project. There is no paper this last week, so it's all programming. Once again, I put a big reminder, do not submit .java files. So either submit, well, for this one, submit a zip file of your source code. You could also, some of you have been pasting it into a Word document or something. That's fine as well, but because there's not too many different classes here. But this one's a little bit bigger than some of the other ones. Similar size to what we just did with Connect 4. So we're going to implement a modified version of the card game called War. In this game, there will be 2 players, and each player will be dealt 26 cards, so half the deck. So you deal 26 cards to one player, 26 cards to the other player. And you already have a deck of cards that knows how to deal cards, right? So you already have that tool. The players do not get to choose which cards they will play. So that's kind of the modified version of the game of War. Typically, the game of War, each player, they have their hand and they just choose, oh, I'm going to play this one. And then the other guy plays the same card and we say who wins. Okay?
I don't know what game you're playing. You just play the top.
Do you always play the top?
Yeah,
Really?
always.
Is there another game that works the way I said it works?
No.
I mean, doesn't that, well, I guess that doesn't necessarily take any strategy out. There should be.
No.
My version would have some strategy. If you remembered what the other guy has already laid out, you might play a card that you know has a good chance of winning based on what he has left in his out of his 26 cards.
No more you deal off the top, you keep putting everything back.
And just cross your fingers?
And you keep going until something.
So this really isn't a modified. This is the game of War. All right, perfect. Okay, so the players do not get to choose which card they will play. Instead, the top card from each of the hands is played. So a total of 2 cards are played. The cards with the higher value wins, giving the player who played it, giving the player who played that card a point. After 26 rounds, the game is over and a winner should be declared based on points. In the event of a tie between cards, for example, 5 of clubs versus 5 of hearts, the tie will be broken as follows. So this is the logic you'll have to build into your game. Diamonds is the lowest value, followed by clubs, hearts, and spades. So in this case, the 5 of hearts beats the 5 of clubs. So the hearts is a higher value than a club. The same type. Does that make sense? So in the end, you'll declare which of the two players won the game based on their total number of points by dealing, having one card go out, comparing the two cards in terms of their values and suits. Remember, I gave you a hint, probably an hour and a half ago or something like that, about remember when you're comparing cards. In this case, you want to compare the face value and you want to compare the suits, not the pointers. Make sense? All right, so questions about what I'm asking you to do.
Since this is all no strategy, like you're not choosing anything, can't you just click run and the whole game will run and then show you the point total?
Absolutely.
That's it?
Yep.
Okay.
Yeah, I would encourage you not to sit there and actually push the button to deal a card. I would just put it in a loop to go through 26 times, so it should literally take your game a half a second to finish. All right, so it shouldn't take your game very long to finish for testing purposes. All right, so questions about the final homework assignment?
How do you want teams being put in our hands?
I guess you can decide. So they don't specify in here. You can treat them all as 10s for ties, or maybe is it usually 10, 11, 12? How are jacks, kings, queens, aces handled in war typically?
I always learned an ace was a 1 and jack, king, queen was 11, 12, 13.
Okay. That's fine. So kind of however you want to handle that is fine. So if that's the strategy you want to use, if you want to say an ace is always a 1. I know some card games an ace can be a 1 or a 10, or no, a 1 or an 11. Is that blackjack? I think an ace can be a 1 or 11. But so why don't we say this? The suggested method for comparing those cards would be an ace is a 1. Then it's 2, 3, 4, 5, 6, 7, 8, 9, 10. A jack is an 11. A queen is a 12, and a king is a 13. If you have a way you want to handle it other than that, that's fine. When I look at your code, I'm looking at just the logic. How did you handle the tiebreakers between suits and that kind of stuff? Okay? All right. Questions, comments, concerns, bribes? Okay, once again, if you are taking the 537 class, which I would encourage everybody in here to take. If you're going to take it eventually, now's probably the best time to take it when all this stuff is at least fresh in your mind. It does start next Monday at 6 p.m. in this room. So no time off. Okay, so I will see you when I see you. Make sure you send me an email when you do finish your final project, letting me know you submitted it, because Angel doesn't let me know, and I will make sure to go on there and grade it and submit your final grade. All right, look, 1 minute early.